in a class, 70% are boys, okay, and 30% are girls, okay, and we got this information, and 5% of boys and 3% of girls, they are irregular, okay, to the classes. They are irregular to the classes. Okay, 5% of boys and 3% of girls, they are irregular to the classes. And what is the probability of student selected at a random is irregular to the classes, and what is the probability that the irregular student is a girl? Okay, let us try to solve that. Okay, so these are the given information which we have. Okay, now for this we can write this as the probability of boys, okay, selecting a boy, okay, so this is 70%, so it is 70 by 100, that is 0.7. And with respect to girls, yeah, is G, that is 30 by 100, that is 0.3. Fine. Yeah. Now let us label this irregular as some variable I. Okay. So if I take the probability with respect to boys and girls, so let us take this probability of I, irregularity, given boys. Okay, this is given boys. Okay, so that is 5%, 5 by 100. And with respect to girls, it is P of I G is 3 by 100. So this will be 0.05 and this will be 0.03. Right?
Right.
Okay. So here it is P of I, irregularity. That is probability of boys and probability of boys, irregularity I given P, plus probability of girl I given G. Okay, so since we have boy and girl, so we have only these possibilities. Okay, now this is what we get as P of I. Okay, so once we calculate this, that is this is 70%, 0.7, and this is 5%, so it is 0.05, and this is 30%, 0.3, and this is 3%, so 0.03. So when you find solution would be 0.044. Now we have to find the probability of selecting the irregularity. What we got is selecting irregularity here, which is this. We have to find now the probability of girl, okay, that is for sure is irregular. That is what we have to find. That is, in the question it was asked like the probability that the irregular student is a girl. Okay, so that is P of G P of I given G by P of I. Fine.
Yes.
So this after calculating you get this as 0.2045. So this will be the answer for that. Now let us see this. A coin is tossed twice. A coin is tossed twice. Is tossed twice. A random variable x. A random variable x represents the number of heads. Heads turning up. You have to find the discrete probability distribution. The discrete probability distribution for x, and also let us find the mean and the variance. Okay, mean is represented as mu. Okay, let us see that. Yeah, you already know that tossing a coin, you get the sample space S, which is head, 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 tail, tail, head, and tail, tail. Okay, and this being the elements of the sum sample space. So we have this total in 4. And to the random variable x, so we know that it is 2, 1, 1, and 0. We have seen this earlier. So it is 2, 1, 1, and 0. Okay. Now let us find individually the probability of getting only head, that is head, head, which is 1 by 4. Probability of getting head, tail, which is 1 by 4 again. Also with respect to tail and head, which is also 1 by 4. And the probability of tail and tail, which is 1 by 4.
Yes.
Yeah. Now let us put that in with respect to one which I was talking about, that is probability of x with respect to where x is related to the number of heads. X represents to that. Okay.
Okay.
So let us write that down. Probability of x is equal to 0. That is no head. No head. So that is getting tail. So that is 1 by 4. Probability of x, that is x is equal to 1, that is getting 1 head. So that is, you have both, that is probability of head and tail plus probability of tail and head. You got that. You had both the cases. So that is 1 by 4 and 1 by 4, which is 1 by 2. Fine.
Okay.
Yeah. Now we'll see 2 heads. Okay. That is 2 heads. Yeah. So this is probability of head and head, which is equal to 1 by 4. 1 by 4. As we have already know that it is ranging from, right, for x and a variable 0 to 1, right? That's what we have done. 0, 1, 2. Now we have to form the table, that is discrete probability distribution. Let us put that also. X as xi. These are x value are 0, 1, and 2, and probability of xi's. No head, 1 by 4. One head, it is 1 by 2. And two heads, which is 1 by 4. Now this is the distribution table.
Okay.
Yeah. About that. So the probability, we observed that probability of xi, which is greater than 0. Did you see that? 1 by 4 and 1 by 2 and 1 by 4, again it is greater than 0.
Yes.
And also the summation of p of xi's is equal to 1. Yeah.
Yeah.
Yeah. So this is done. Now let us find the mean and the variance. Let me give you the formula. Okay. Let's find the mean and the variance. So mean, which is nothing but mu. The formula is summation of xi into p of xi. This is very, very important for I. So I, which is ranging from 0 to 2. Okay. So
Yes. Okay.
yeah. So we have the first one. You see this. This is 0, x0, x1, x2, and this is p of x0. This is p of x1 and p of x2. Okay. So you have to multiply that. First one, you get 0 and add because it is summation. No? Next is 1 into 1 by 2. Next is 2 into 1 by 4. So you get the mean, which is equal to 1. Fine?
Okay.
Okay. Now let us find the variance, which is V. So summation, and this is xi minus mu whole square multiplied into p of xi. Okay, we already found what is mu earlier. Fine, so it is 0 minus 1 whole square into p of x0, which is 1 by 4 plus 1 minus 1 whole square into 1 by 2 and 2 minus 1 whole square into 1 by 4. This is equal to, after simplifying, we get this. So here mean is 1 and variance is 1 by 2. So we found what is mean and what is variance. Okay. Yeah.
Yeah.
Yeah. Now, a random experiment of tossing a dice twice. Okay, a dice is tossed twice, right? And the random variable x on this sample space is defined to the sum of the two numbers turning up on the toss. Okay, and then find the discrete probability distribution for the random variable x, and let us compute the corresponding mean and the standard deviation. Okay, here standard deviation also we'll find. Okay, now we have a dice which is thrown twice. Okay, so let us call this a sample space S. Okay, and x and y. Okay, and
Okay.
where x is with respect to 1, 2 and 6 with respect to the first die, and y is with respect to the second one, 1, 2 and so on. Okay, yeah. Now we can again write this as 1 comma 1, 1 comma 2 and 1 comma 3 and so on. We get 6 comma 6 because we have two dice thrown simultaneously. So also we can also find the n of s, which is nothing but 36 square. Right? This is what is given in the first one. Okay. Now also the set of the random variable x defined. Now they are defined like this: x variable. Okay, such that the sum of the two numbers, which is the sum of the two numbers, that is x plus y. So we have already seen that the sum. Now this will be with respect to x, right? So that is 2, 3, 4 and 12. Okay.
Okay.
Yeah. Now let us look at each and every thing in detail. Okay. Let me put in a tabular column so that we understand this better, what is going on. Okay.
Okay.
Yeah. First, let me put the elements of the sample space. Okay, here, and the x is put to xi, and the total number of that events which is occurring. Okay, so in the sample space, let me consider the first one, which is 1 comma 1. So here we have x1, the first one, which is x1 plus 1, which is 2. So that is happening how many times? Only one, right?
Right.
Next is 1 comma 2 and 2 comma 1. So this is when you put this together, you get 3. This is happening twice, 2 times, no? Here 1 comma 2 and 2 comma 1. Fine.
Yes, sir.
And now here 1 comma 3 and 3 comma 1 and 2 comma 2. See here, this will be 4. When you add this, 1 plus 3 and 3 plus 1 and 2 plus 2, which is 4. How many such? You have 3. And now the next thing is you have to get here as 5. Right? So 5 means you should get 1 comma 4, 4 comma 1 and 2 comma 3 and 3 comma 2, right?
Yeah.
You get 4. Fine?
Fine. Yes.
Like that you should get for 5, okay? For 6, so this will be like 4, this will be 5, okay? And this will be 6. Fine?
Yes.